All right, let's work on another problem. So this problem is LeetCode number 238, product of array except self. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. This algorithm must run in linear time and without using the division operation. And the product of any prefix is guaranteed to fit within a 32-bit integer. So I actually did a little bit of thinking on this one yesterday as well because I had time. It turns out that road trips are great for thinking about LeetCode problems. Anyways, the straightforward solution, I think, when it comes to this, before the follow-up, right? We'll think about the follow-up in just a little bit, is that when you think about it, when we go left to right, we have, and we construct an array of the products, we have indexes of, so this will be 0, then 0 times 1, then 0 times 1 times 2, and so on and so forth until 0 times something until n, right? So if we go left to right, we start at 0, 0 times 1, 0 times 2, blah, 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 all the way to 0 times all the numbers in the array. If we go left to right, and we just multiply each time. When we go right to left, then we start off with n. Then we do n minus 1 times n, right? Then, this is weird typing backwards, n minus 2 times n minus 1 times n, right? And this can go on and so forth, right? Until we go to n times some amount times 0. Or the initial number, right? And again, the first number in this case is equal to the last number in the left to right, which is just the product of everything. Now, what we notice is that, something that we can notice is that when we do a product except self, this ends up being the left to right is equal to the left to right product of 0 to n minus 1, right? So all the numbers from the left side until that number multiplied by the right to left of n plus 1 to n, or not n plus 1, we'll say I, right? We'll say I, because n is, we're reserving n as the number of elements within the integer array. So we go from, so the product except self is equal to the left to right from the first until the one before, multiplied by the right to left of, we can say actually this one is n, all the way down to I plus 1. So we can actually do, so this simpler solution, which is not brute force. So we can talk quickly about the brute force. The brute force solution is just to say calculate it manually every time. So very similar idea of going from 0 to I minus 1 and then I plus 1 to n, but we would be calculating it manually every single time. This would take, because we need to make essentially n minus 1, a scan of the n minus 1 of the array for all n values, we would basically have O of n minus 1 times O of n, which is essentially equivalent to O of n squared, right? So this is the brute force solution. But there's a lot of leftover, or not leftover, there's a lot of redundant work that's being done there. Rather than recalculating it every time, once we do this one time, we know what the product at the 0 index is. We know the product of the first index going from the left side, and so on and so forth. We can calculate it once, and we don't need to do it again, right? So that's the simpler solution, where we run 2 passes through the array, through the input array to build up the left to right and right to left arrays, then use those cached values to build the output array. The time complexity of this is O of n, because even though we are doing 3 passes technically through nums, right? Once left to right, once right to left, and then building it. We are doing this 3 times, technically. It doesn't really matter within the context of linear, within the context of big O notation, right? It's still linear as long as we are doing it a constant amount of times and not something that's related to our input size. However, the space complexity in this case is also O of n, because we need to create these 2 arrays, not including the output array, which will hold our values. So that's just how it is. The slightly more complicated, optimized-ish version that I thought of in the car. We could probably get away on the right to left side, sorry, left to right side with an accumulator. Basically, we just have a single integer value and then we multiply it as we run along. So we don't need that array, but we still have one more array to deal with, which is the right to left. In that case, we could probably reuse the output array and slowly fill in the values as we get there. So we override the values, rather. So we use our output array as one of the arrays for our data, for our algorithm, but it's fine because we use that array again as our returned value. So that's fine. So, and within the context of LeetCode, they say the output array does not count as extra space for space complexity analysis. So we can actually use that array. It's a little bit cheeky, but it works. It works. And in this case, the time complexity is actually still O of n, and it actually might be better this time because we don't actually run that first pass for the left to right array. So we save on one of the passes at least. And our space complexity in this case is now technically O of 1, or constant space, because the array that we're using, the only additional array that we're using to store data is the array that we will be returning. We do use it for additional values later on, but that is not something that we need to worry about at the moment. So I think this is the more optimal solution. I think this is fine. There may be a better way to approach this that even like simplifies things, or simplifies things even further, but I'm not too sure on that point at the moment. But I think this is good enough, so let's get started coding. So we will start with our output array. We will create an array of size num size initialized to 0. Then we will say nums, let's see, we can say for I in nums.size -1 down to 0. So this will go from starting from size -1 down to 0. This is also Kotlin stuff. We will say output array at I is equal to output array, actually this can be 2, I plus 1 times nums at I. And we can say output array at nums.size -1 is equal to nums at nums.size -1. So we just take that last value. And then for each value within our output array, starting from the second to last, we'll take that element that came in after us, to the right of us, and we'll multiply it by our current within the numbers. So this should populate the output array with the values that we need. So now we can say output array for each indexed value. And actually, let's use a for, we can use I again in 0 to output array size -1, because we're going to be modifying it, and I know that Kotlin can be a little bit stingy on the concurrent modifications, so let's just do that instead. So we start at the left side. We will say output array at I will be equal to, and we need a var accumulator is equal to 1. We'll say it's equal to our current accumulator, which is our left to right, multiplied by our output array at I plus 1. And this should stop at that point. This will be a little bit messy with the way that we handle it, because we need to take our right value. So we technically can't go to our last value, so we'll have to do like output array at output array.size is -1 is equal to our accumulator, which is our right to left, at the end. And then our accumulator multiplied equal our nums at I. So, sorry, I was just looking at the test cases because I wonder if the zeros are going to mess this algorithm up a little bit. In any case, I think this is my sort of initial draft of the solution. We create our output array. Then we first set our last value. Then we populate the rest of the output array as we did previously by going left to right, and we just multiply each time. Then we create an accumulator. We started off with 1 because when we multiply it, we probably want to make sure that it's at least starting off multiplied by 1. Then we set our output array value to our accumulator multiplied by our output array I plus 1. So that's the right-hand side. And our accumulator is technically our quote-unquote left-hand side. And then we'll actually make our accumulator multiply the current number for the next value. Then at the end, because our value is, because we don't have a right-hand side at that point, we set our value on our last one to the accumulator, and then we return it. So that seems to make sense. Let me just double check. I wonder if this down to is going to cause problems. I don't think it did last time I tried to use the down to function, but that might be an issue. We'll see. Let's go ahead and do a run code quickly, just to see if there's any compiler issues. Oh, it expects an int array. Okay. And I wonder if int arrays still require... I don't believe int arrays require that initialization step then. Okay, so that worked. Let's toss in the second example. LeetCode, come on. Okay, that seemed to work. So, let's see. Is there anything here that could screw us up? The minimum number of elements is 2. What happens if we toss in an elements array of 2 here? Well, if we toss in an element or an array of size 2 into our input, essentially those values would just be swapped, right? And does that work within our array, or within our algorithm rather? We create an output array. Our output array, we set our last value to that one, and then we set our initial value to the product of that. Then we set that. Then we set that. Then we set the right to left, and we set the left to right. This goes to the size -2 though. So our accumulator, so our first value, wait, -2, okay, so that would be 0, okay, for 0 to 0, so it's inclusive, so that actually should work to bring the right to the left, and then this gets the accumulator, so the accumulator saves that value. So I think it should work. Let me just double check to make sure that it does. Okay, cool. Let's toss in a submit. Okay. Looks like we were still a little bit on the slow side though, interestingly. Though this is an O of n solution as far as I know. Perhaps there's a way to speed it up even more. But I do wonder. Interesting. I'll have to take a look into this later on because, again, I've got a meeting in half an hour, so that's what I'm worrying about. And I've got other things to do. But other than that, I think this is a pretty good solution. Like, it runs in linear time as far as I can tell. It uses the constant space if you don't count the output array. Maybe there's a solution that doesn't include using the output array at all as a store of value. But I mean, this parenthesis seems to imply that the output array not being counted as space means that it's fair game to store values. So I'm not too sure. Maybe there's a way to do this without doing that. But you can't use division, so you can't just start with the right to left and then divide from there. It's an interesting question, but honestly, I'm just happy that I managed to find a technically constant space solution while just thinking about it in the car. But in any case, I hope you learned something, and I'll see you for the next problem.